Welcome back to the channel. In this video, we'll discuss about recursion in Java programming language. So in this session, we'll discuss about recursion in your Java programming language. So recursion is a concept that is related with your methods. So in previous class, we discussed about your methods. Okay. So we have seen how to create the user-defined methods. We discussed about how to create the user-defined methods, right? We have seen the syntax to create this user-defined method. So first of all, in this session, we will look about multiple user-defined methods, how to do that we will see. And next one is we will see about how to call the user-defined methods recursively, that we will see, and how to avoid the looping these particular statements that we will be covering. So what is recursion here? Recursion in Java is nothing but it is a process of a method calling itself is known as a recursion. Means what? A method calling itself is known as a recursion. For example, let us assume that there is a method. So for this method, I told you that there are two things will be there. If you treat this as a method, another method is there. Okay, this method is going to call this method. Okay, in this scenario, this is known as a called method and this is known as a caller method. This is what we discussed in the previous class, right? So one method is called by another method. For example, let us assume that I have a method with the name main method. In this main method, I have two sub methods. First method is add is one method and subtraction is the another method. Subtraction is written somewhere else, so with some code, and addition is written somewhere else with particular code here. So whenever I call add, this particular add method will be executed, and whenever I call this subtraction method, this method will be called here. So in this case, our main method is known as a caller method, and this subtraction and addition are known as your called method. If you observe in this scenario, what is happening is there are two different things. That is, one is a caller, another is a called method. Both are different entities. Whereas coming to the recursion, both these two entities will be the same function. Okay, for example, so the caller and the called method both are same. Both are same. A method M is calling itself again and again, again and again. This process is known as a recursion, and this is known as a this type of methods are known as your recursive methods. This type of methods are known as your recursive method. The process of calling a method by itself is known as the recursion. Hope you understand clearly what is recursion. Okay, so we can see simple code we can take here, like so a return type is there and method name we are going to specify, and then you are going to write the method name here. Okay, for example, I'm going to like a factorial of n my n. Okay, inside this I'm going to call again factorial of n minus 1. Initially, let us assume that n is equal to 5. So with the 5, it will come here, it will go inside. Again, 4 minus 5 minus 1, that is equal to. So again, it will be calling the same function as fact of 4. So again, it will come inside, and again, n minus will be 1, 4 minus 1, that is equal to. Again, since it was coming with 4, 4 minus 1, that is equal to 3. Again, it will be calling the same method as fact of 3. With the 3, it will come inside 3 minus 1, that is equal to 2. It will call the same function as fact of 2. Right, again 2 minus 1, again 2 minus 1, again what happens? It will call the same method as fact of 1. Right? So in this way, it is going to do the same particular task here. Recursively, it is going to call this particular same function it is going to call. This is a simple example of a recursive function in Java. Hope you understand clearly. So, but problem with this one is when the same method is going to call itself, what happens? It will form a loop. Okay, it doesn't know where to terminate this calling procedure. We should stop somewhere, right? When you take a normal loop, I'm having a condition like while I less than 5. Whenever I value becomes 6 less than 5, this condition fails. So the loop will be terminated and it will go outside of the loop, right? So this is the end of the loop. So what is the end of this recursive statement here? Okay, what is the end of this particular recursive method here? So it will form a loop. So you should be careful with this one. So let us go and see some more examples about your recursion and how to remove those particular things. Okay. So now what I'm going to do is we are going to take a main method here. Okay. In this main method, we are going to create some static variables. Static variables that is nothing but fact equal to 1 and I equal to 1. Okay. Static variables are fixed, right? They need not to be initialized. I mean, they need not to be created here. Okay. So f is equal to 1, I equal to 1 here. So public static. So int fact or of int n value we are going to take and we are going to pass that particular value here. Okay. So next one is it is going to what this function is going to do here is it will just calculate the factorial value f is equal to f into I. It will take one value and 1 into 1 it will do. It will increment the f value and further it will be incrementing the I value. I plus plus. Okay, again I value will be incremented. Initially it will be 1, again it will increment, then it will become 2, again 3, 4 like this it will become. But I wrote a condition like while I less than or equal to n. Okay, whenever I value becomes less than or till I is less than or equal to n. For example, I want to do it for 6 rotations. Okay, then until unless this value reaches here, when I value reaches 6 or when 6 plus 1 that is equal to 7, whenever I value reaches 7, this is going to terminate this particular condition. Whenever this is true, then it is going to call this one until unless this will be calling this one, otherwise it will not call this one and it will just return the f value here. Okay, it should be like for 1 it will be calling this one. Okay, for 2 it will be calling, 3 it will be calling, 4 it will be calling, 5 it will be calling, 6 it will be calling. But when the 7 is going to come, this condition fails here, so this will not be executed and it will come to the final return f value will be returned. Okay, so this also we can do with the help of a this is a recursive function, right? So here we are not using any loop here. Okay, we are not going to use any loop here. You see clearly, we are not using any looping structure here. But same thing can be implemented with the help of a loop here. So here we are using a looping structure. Here we are using a looping structure. In this looping structure, we are initializing again f value equal to 1, I equal to 1. Do f is equal to f into I. Okay, same statement we have written and I will be incremented while I less than or equal to n. So instead of this condition, what we are doing is we are just writing this particular condition. Again, until unless this value is going to be breaked here, it is becoming 6. We take 6, same 6 we are taking until unless this value is equal to 7 less than or equal to 6. So this condition fails here. So see that is a recursive function how we are going to write, and this is where we are going to use a loop and we are going to write the same recursion here. Okay. Thanks for watching the video. Please like the video, share the video and subscribe to the channel. See you in the next video. Thank you.